Welcome again to the next section, existential generalization. I said existential instantiation. What it meant was existential generalization. It runs something like this. First of all, let me write the topic up here. Existential generalization. The argument runs something like this. In fact, it's right there in your book on page 448. All humans are mortal. Socrates is human, therefore someone is mortal. All humans are mortal. 2. Socrates is human. 2, 3. So someone is mortal. Well, if Socrates is human, then it would mean that Socrates is mortal. And if Socrates is mortal, then it means someone is mortal. Let's see if we can... I noticed that there's a glare. Let me try to avoid it here. I hope it was not in the other videos. Look at them and see. 1. All humans are mortal. Pardon me, I'm supposed to be symbolizing this. This is the way it's supposed to be. For all x, if x is human, then x is mortal. Socrates is human, so that's how it'll look like. Therefore, someone is mortal. There's an x such that x is mortal. Now, how do you move from this to that? Construct your proof in the following way. First of all, do universal instantiation by replacing all the instances of x with s, so that what you have now is h, s, and s, and you will say 1 universal instantiation. And then you do modus ponens between 2 and 3. You have ms, and you say 2, 3 modus ponens. And then, if Socrates is mortal, it means someone is mortal. So step 5, you simply add the backward-looking e and say 5 existential generalization. That's how you do it. You can existentially generalize from a constant. Okay? You existentially, let me put it here. You existentially generalize from a constant. You can actually existentially generalize from a variable. Some books allow you to do that. This book doesn't seem to allow you to do that, but it's not illogical to existentially generalize from a variable. But you need to existentially generalize from a constant if the argument presented is such that the conclusion is an existential generalization. Rule of thumb: anytime you see a conclusion that has the existential generalization sign, it means that somewhere your last step will be existential generalization. It's not always the case, but it seems to be a rule of thumb. Again, existential generalization can be applied only in whole lines. Cannot be applied on parts of a line. In much the same way, for example, that you cannot do modus ponens on a part of a line, you cannot do modus tollens on a part of a line, you cannot universally instantiate on a part of a line, you cannot existentially generalize on a part of a line. It has to be a whole line, a complete line. So with that in place, you can see the instances of universal instantiation on page 448 and instances of universal generalization on 450. If you're using this book here, though, you will discover that they have a typo on page 448 under correct applications. They seem to have a typo there. Look at the first example. The first example is fine, where you have this here, 1 for all z, f z, and then 2 f a, and then they say 1 ui. That's okay. But look at the next one, directly below it. You have 1 existential generalization. You have this dx dot ex, and then step 2 you have db dot eb, and then they say 1 ui. That's not ui. Universal instantiation only deals with universal statements. That is really supposed to be a universal mark. They don't need that. What they need is just that, to give you UI. So that's the typo that's in that book. Apparently they've corrected it in the later edition. Okay, that's all you need to know about existential instantiation. Oh, sorry, existential generalization. Now I promise you that in the next presentation you will have existential instantiation.